Okay, this is Unit 5, Target 6, proving triangles are similar. This slide says that in these proofs you're going to use your different similarity theorems, angle, angle, side, 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 angle, side. You also use the reflexive property, a couple definitions, scale factor, proportional sides, and then a few theorems from Unit 2 and Unit 3. All of these theorems are on your theorem sheet, so you can reference them as you go. And then please use these proof examples I'm going to do one example per video. Use these examples to help you with the proofs on your homework. Here's the reflexive property, definition of scale factor, definition of proportional sides. And then here's the different similarity theorems for the triangles. So I'm going to refer back to these as I go. All right, example 1. Have this triangle, big triangle RST. We're trying to prove triangle RST is similar to PSQ. So first you just need to make sure you see what triangles you're talking about. So RST is there in green, and then PSQ in pink. So little pink triangle, big green triangle. Okay, it says given segment lengths given in the diagram. So that means I know SP is equal to 4, SQ is equal to 5, PR is equal to 12, QT is equal to 15. So just by looking at the diagram, I can see that I have two sides of the triangle given. I don't have 3 sides. So if we go back here, I don't have side, 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 similarity theorem. I do have 2 sides, and then the top one talks about angles. And they didn't show me any angles yet, especially not 2 of them. So going back to the example, I have 2 sides, and then we talked about in class, they have this included angle S. So I have 2 sides and an included angle. The pink triangle has angle S, the green triangle has angle S. So I'm going to be using this side angle side similarity theorem. The theorem says if an angle of one triangle is congruent to the angle of a second triangle. So in this case 70 and 70, or in ours, angle S and angle S. And the lengths of these sides, including the angles, are proportional, then the triangles are similar. So I need to show that, like in this diagram, the 6 and the 2 have the same ratio as the 15 and the 5. So 6 over 2 is equal to 3. 15 over 5 is equal to 3. If I can show that both sets of sides have the same ratio, then that means the sides are proportional. So the very first thing we're going to do to start is find out what their scale factors are. So I said PS and RS. So PS, that's the side of the pink triangle. That's the left-hand side of the pink triangle. RS is the left-hand side of the green triangle. The left-hand side of the pink, or the left-hand side of the green, is 4 over 16. Yeah, 16, not 12, because this whole side is going to be 4 plus 12, so 16. 4 over 16 reduces down to 1/4. We call that definition of scale factor. I'll go back to that definition in a moment. My second step is to look at my other side. SQ is for the pink triangle. It's equal to 5. ST is for the big green triangle. It's equal to 20. Okay, 5 plus 15 gives you that 20. 5 over 20 is also equal to 1/4 definition of scale factor. So if I go back up and look at my definition of scale factor, scale factor is the ratio of the lengths of corresponding sides. Apologize, my voice is faltering a little bit. Still have this cough. So 10 and 2 in this diagram are corresponding sides. So 10 over 2 has a scale factor of 5 to 1. So basically in our proof so far, we've identified the scale factor. Scale factor of these 2 sides is both 1/4. The reason that we did that is because the definition of proportional sides. That definition states if the corresponding lengths of the figures have the same scale factor. So I need to show that they have the same scale factor. If that's true, then the sides are proportional. So remember, if then. If is on the front of the arrow, then is on the back of the arrow. So if I have two sets of sides with the same scale factor, arrow, then those sides are proportional. So I took those same things. This time I flipped it over for some reason, RS over PS. So for some reason I switched up the green and the pink. Okay, you can just keep it as pink over green, doesn't matter. And actually I just double checked the right hand side. It looks like I meant to keep it the same way and I flipped it over. So let's just change that. Sometimes that happens. So since the SQ is the one on top, I'm going to be looking for PS on top. Since ST is the green big one on the bottom, I'm going to be looking for RS. So PS over RS equals SQ over ST. We call that definition of proportional sides. We started with scale factor, and then we went to definition of proportional sides. So now I have two sides proportional. So I have two of the things I need. I just need the angle. So I also am going to say underneath that number 4, angle S is congruent to itself. We call that the reflexive property. Angle S of the pink triangle you could say is angle PSQ. Angle S of the green triangle is RST, but that's the same angle. So once I have the angle and I have the two sides around it, I can say the triangles are similar because of the side angle side theorem. So side angle side similarity theorem. So this is how I would do a side angle side theorem most of the time. Or if I'm doing side side side, I'm going to start with those same first 3 steps. So if you are on a test and you're trying to use side angle side or side side side, you're going to use this order of steps. Tell me the scale factor, then use those same letters to give me a statement to show they are proportional.